Good morning and good afternoon, everyone. Welcome to today's Gala webinar. There is quite a crowd for today's webinar, so we're going to start in more or less a minute to give everyone the chance to log in and settle. So please be patient, sit tight. We're going to start shortly. In the meantime, you see a poll on the screen with 3 questions. I invite you to answer those questions so that both presenters, Konstantin Savienko and Michelle Lopez, they can kind of get to know the attendees of today's webinar. So let's see. Still a lot of people logging in. And once you've replied to the questions in the poll, you can write in the chat where you are joining us from today and any questions you might have on MT. We have 2 big experts, so fire away. They're ready to answer all of your questions. Okay. Okay, I think we can start. I'm going to close the poll in 10 seconds. See, the people are writing in the chat. Okay, Philadelphia, Berkeley. Okay, Egypt, wonderful. Okay, I'm going to close the poll and I'm going to share the results. So for now, we have 29% enterprise, 61% LSPs, 10% technology providers, and then 82% already use MT, 18% are planning to use MT, and then 67% have projects where they may have to make sure that their linguists do not use MT, and 33% do not have this problem. So thank you all. So as I said, welcome to today's Gala webinar. My name is Isabella Massardo. I'm content strategist here at the Globalization and Localization Association. Today's webinar is sponsored by Intento and presented by Konstantin Savienko, CEO of Intento, and Michelle Lopez, CEO of E2F. We will have a Q&A at the end of today's presentation, but feel free to use the QA box to submit any questions you may have for our speakers. And I invite you to do so throughout the presentation as you think of them. The webinar will be recorded. I will send a follow-up email when the recording is published on our website. So Konstantin and Michelle, I leave the virtual floor to you. Good luck.
Thank you.
Thank you, Isabella. Thank you. Hello. Actually, there was a mistake on the first slide with both speakers. Today we want to present you State of the Machine Translation report, which we together prepared and published in September. It was a few months ago. Already many things changed, as we just discussed before. We've seen more than 100 new languages added to machine translation since then, which is terrific. Still, I do believe that most of the models are still general public models, pretty much the same, so that you can use our report to guide your journey. Michelle, any first words from you?
No, just to say that it was a pretty extensive effort on our end to prepare. So we did that in I think it was May and June, if I'm correct, and I'm going to describe later what we did.
Yeah, so it took roughly about, I think, 4 months to prepare the report. And this report is basically independent evaluation of all commercially available machine translation engines we could find and we could get access to evaluate, perform it on the best data we could gather. And this year we evaluated 31 machine translation engine from about 28 providers. And also this year we used a unique data set built just for this report in partnership with ETF, who helped us to translate close to 1 million words and make sure that the translations are high quality enough, and which is important, that they're not machine translations. And the data set covers 9 content domains and 11 language pairs. We'll start from just quickly introducing the companies. So quickly real what Intento to do. We enable global companies translate much more content on the same budget and also make their customer and employee experience instantly multilingual in real time by directly integrating to tools like Salesforce, ServiceNow, and so on. And we have a product that's called Enterprise Machine Translation Hub, which augments best-of-breed custom and empty platforms with some of the advanced tools we develop ourselves. And those tools primarily do source quality improvement and automated post editing, so that end users are more happy. And if there's a post editor which needs to still improve the quality, they spend less time doing that. And during this process, we must evaluate and customize empty systems for specific content and use case. Not every use case may deserve the dedicated MT customization and evaluation, because, you know, when you work with custom machine translation, it's not only effort to customize this model, but also effort to maintain this model. And it costs significantly more, translation costs significantly more. So that's why we make this once a year, we make this broad study to see how things are in general, not for specific content of specific company, but in general for different domains. And as we just discussed, it takes quite a bit of effort to run such a study properly. So we believe that just this information about how different pre-trained stock machine translation models perform on different domains just needs to be available to any MT user. So that's why we make it public for free every year for the greater benefit of the industry. Yeah, Michel?
So I think we are quite known in the industry, in the language industry in general as a localization company. But besides localization, we in the last 5-6 years, we've been working a lot with large tech companies to help them either build or improve the quality of AI engines. We do that for a number of applications, mostly around speech, actually, around ASR, speech recognition, NLP, natural language processing, NLP, NLU, but also for search relevance, for large search engines, and as well for machine translation. So we've been helping, two of the largest MT providers to improve their translation engines, and the way we are doing that is by building data sets that are as high quality as possible from a human translation standpoint, and also as we were mentioning before, absolutely free from machine translation. So yeah, you cannot. It would be really bad for a machine translation engine to, without their own knowledge, have the content that they use for training of the AI being actually coming from another MT provider or from their own actually. So we have developed some pretty sophisticated MT detection tools that enable us to, as our own freelancers, linguists, contractors, translate the content we provide to them. We have sophisticated ways to make sure that they do not use themselves machine translation in the process, so we can quote unquote guarantee when we deliver to our client that our content is free from any traces of MT. So I think that's also why I was interested when Konstantin reached out to us, because we knew that the purpose of this report, it is extremely important that the report not being unknowingly biased towards one engine or the other, because the translators building the dataset themselves use that engine that would then pop up as the best engine in the report. So we just want to make sure, and it's very important for Konstantin to make sure that this is not happening. So that's why he reached out to us for that. So again, yes, we are a localization company with supporting a really high number of languages, but we are also a data company. So that's we're kind of at the crossing of data, technology, and languages. Back to you, Konstantin.
Yep. Thanks, Michel. We already have some questions, but let's maybe discuss them closer to the actual material. Where we'll be talking about, I see a question about MT detection, which we can discuss on the data preparation part, and also some about the providers. And actually, next slide. This is the on this slide, you can see the full machine translation landscape as we see it. Basically, of course, there may be some machine translation engine which is built in some garage, which we don't know about. But that's what we know about. And it's quite important. We included here only MT engines which are available to use for other companies. There are some machine translation engines which are developed internally by companies, either by enterprises or by LSPs. Like, for example, there's Lilt, there is machine translation engine at Bible, but it's hard to use it for your needs if you're not buying some of other services. It's not, they do not present on the market as machine translation engine. We do not include it here. So some time ago, this landscape was split by technology. We had blocks with neural machine translation, statistical machine translation, rule-based machine translation. Well, these days are long gone. Oh yeah, and this report we published it since 2017, so it's basically 6 year. Today, all machine translation engines are neural machine translation, mostly. There are some rare exclusions. There are still for cross-dialect translation, you may see rule-based engines, for example, Aperture, which is commercialized by Promzit, but most of them are NMT. And today we split them by customization possibilities. As you may see, there is a broad range of MT systems with pre-trained machine translation models. Stop. And actually, not all of them fit on this slide. So there is it's reduced version of the slide. Sorry, it's not full landscape. Sorry, you can get the full one in the report anyway. But yes, some are not visible here. Then several MT vendors provide models pre-trained in specific verticals. For example, Alibaba, they have for titles and descriptions, and also for communication with customers. There is other vendors providing. There's Royal Flush, which is not visible on the slide, sadly, but it provides engine in financial domain. There's cloud translation with medical domain. Also, Katoha has, which is a Japanese provider. They have engine for for medical domain. Then there's a group of MT systems with custom terminology support, also known as glossary support. So it's not training, but you can upload your glossary. And in some cases, it will be just used as a substitution. In some cases, it will be substitution with morphology changes. For example, at DeepL and Systron, it will take morphology into account. Then there is a group of MT systems which can automatically train on your translation memories. We call it automatic domain adaptation. And this year also there are some new, at the last AMTA conference, which we run in September, this automatic domain adaptation was split into large two blocks. We sort of agreed to call it differently, those two blocks. One is a static domain adaptation, where you upload your translation memory and you train the model in one step. And second is dynamic adaptation, where you can train on every sentence, a sort of more lightweight approach. And this approach is used by companies, by providers like Modern MT, Amazon, Kantan, some others. So next report, it will be split. And also possibly next year, we'll also show open source models as a separate block. And then finally, there's manual domain adaptation, where you don't have an interface, but you can just send your TM to linguist team of the provider, and they will train model for you. Probably it will be a little bit more expensive. So, okay, I see. I know that we have Q&A block where Isabel is helping us with selecting questions. I see there are some questions in the chat as well. Speaking of, I see a question that there are some machine translation engines which are less known, and should they be integrated with TMS? You will see if they work better on your content. You can actually try many of them through demo section of Intento website to see if they work better on your content. And if it do, most of these machine translation agents integrated to Intento platform, for example. So you can quickly try them through our connector in your TMS and then decide. You can, swipe your credit card, start a trial, try a few of those engines and decide if they work for you. And then if they work, then you can use them. So on the next slide, you may see engines which we actually evaluated in this report. You may see here 28, I believe, providers. And from one of these providers, we evaluated a few models, which is Meta, because Meta published just 2 weeks before we published the report. Meta has published, I think, 3 or 4 pre-trained open source models, which are called No Language Left Behind, NNLB, with which are large multilingual, massively multilingual models doing translation many lower research languages. So we decided to include them in this report. We've done it. So from Meta, there are a few engines, and I believe there are 2 engines from Alibaba, because they have general engine, they have e-commerce engine. Then what we should have shown, but we didn't show them separately, for Systron, we evaluated a specific domain. We evaluated domain-specific models, which you can find on Systron Marketplace. So there are domains trained on Systron platform for different models trained on Systron platform for different domains, and we evaluated domain-specific models there as well. Okay. Yeah, so I think if possible, if you will ask questions in the Q&A, they will be more visible just from the conversation. So I think let's leave chat for the general conversation and have questions on Q&A. So what we show here also, here we evaluate only stock models. We're not doing glossary adaptation, we are not training them. But we want to show customization possibilities. So when you select what model to use for your own purposes, you see where you can get additional boost of quality based on the data assets you have. So you see, for some of them, they support training on TMs, some of them support glossary adaptation, some of them support both. It's shown by these circles. Yep. Okay, so then maybe before we go to the data sets, we may address questions, quick ones. What's the minimum word count a TM must have to be run in the engine for training? So that depends by the platform. Platforms which use static domain adaptation, they require typically technical limitations, typically 1,000 segments, where you may expect substantial boost in quality around having 10 to 20,000 segments. But the very important thing to remember, it's not about word count, it's about number of segments. And then it's important to understand that even perfect translation memory for humans, it's not all perfect for machines to train on. So during this cleaning process, you probably will have to let go from 60 to 80% of your segments. Because one of the biggest reasons for that, for the sake of in context matches in your TM, you have multiple instances of one segment. And machine translation trains on only one of them. So when you remove those duplicates, you're typically left with 20 to 40% of what you had before. So you should, like the rule of thumb we use that you should have about 45,000 segments in TM, so that after cleaning, it may be, you may get some benefit from training. Second question.
I think I'll address it in my. I will address it. I think just
okay.
In the next slide. Awesome.
And then let's take another question related to integration. All translators these days have plugins to use MT in their translation environment. How you can reliably determine that MT has not been used to use the text that you have to the data set? Yeah, we addressed it. Okay. So then let's talk about actually data sets. First part, I think actually, yeah.
Right. So the way we prepare the data set is what was very important for both Konstantin and us is to make sure that the data set can be what's called a golden data set in the industry, which is kind of a reference. So in order to do that, two things were very important. First of all, that the content is well selected and not publicly available as far as their translation. So in previous years, what Intento had been doing is using more like public domain data sets that where the translation was also public. So that could be
maybe
some kind of bias.
Let me address this historic part. So like first reports we actually run on using public WMT data sets, which are available to all MT providers and everyone. And we noticed difference between what we've seen in those reports and what we've seen in commercial evaluations when we evaluate on customer content, which no one of those engines seen. And also we wanted to do in-domain evaluation. And when we analyze the domain specificity of WMT data, they have some domains, but if you look, those domains very often based on keywords, and the segments very often actually out of the domain. They just have this keyword. So you have like virus and death, it may go to healthcare domain, although it was about computer viruses. Sorry. And the previous year, we used TAO's data, which is high quality domain data, but it was the same data sets which TAO sells to MT providers, and some of them purchase them. So some of the providers got unfair advantage from that. And this year, we decided to develop data set from scratch. We collected 500 segments per domain using monolingual public data. And we checked that there is no translations available online for those data sets. And then ETF helped us to translate it to 11 languages. And yes, Michel, I covered the historical part.
Yeah, so the part of our process is, what you would normally do as a localization company, to select the best translators you can find for the different domains. Also have your best reviewers and proofreaders. So I mean, there's nothing new here for a localization company. However, the quality assurance process was kind of specific, and it's the kind of, again, as I was mentioning before, the kind of process we use when we work with MT providers themselves. So we have a pretty sophisticated algorithm where we actually, for each single string, we compare the human output with the output from a lot of different engines, and then on a translator by translator basis, we calculate kind of the distance between the translator and different engines, and then we do that for every single translator. We also compare translator to translator to see whether the patterns are identical or not. And the whole process is, the result of the whole process is to evaluate on our end a degree of suspicion that this or that translator may be using this or that particular engine. And then once we raise this level of suspicion, then we stop the translator, and then we have our reviewer evaluate whether it's really clear that this or that particular engine was used in the process. So it's also, it doesn't work in absolutely every single case. So if a translator would develop their own machine translation engine that we don't know about, we could not figure this out, but it still works if an engine has been trained with additional content, because the output still bear traces of the general purpose engine your engine has been built upon. So it worked really well. I mean, we never guarantee that it's going to work 100% of the time, but it works really well. Actually, for this project and for projects we do with MT providers, so we flag translators like pretty quickly in the process. There are some false positives in and there, but again, those are eliminated by a human review. And then so besides just the MT detection, so we also did took extra care to make sure capitalization, punctuation, spelling, number of spaces, and typos are like eliminated. That's really important. Again, we are talking about a golden data set here. So you're looking for, I wouldn't say perfection, because we all know there's no perfection in translation, but as close as possible as what you can do as a language company.
Yeah, and also one thing that we discussed, I think it may be important here, we had to decide, should we go for literal translations? Because we all know that machine translation mostly does literal translation. So we should go to humane translations. And we decided that we go to humane translations in this case, because our goal is to make a data set helpful to people using machine translation in real world.
And actually, that's very relevant, because if you're talking about the best machine translation providers out there these days, when I see the project they are sending us, they are really trying to address. They used to address, the meaning aspect and the fluency, and now all of them are really, they feel that they've addressed that pretty well already. So they're all working on, on nativity, right? Making sure that not only the content is fluent, but it really sounds native. So that's and I think that's, if you want to evaluate them on nativity, the data set needs to be as native as possible. So again, besides fluency, is really more like naturality. Right?
And maybe one question also we take related to data cleaning, which is, I think, very interesting question, which is there are many ways to work. So the question is that for engines like modern MT that allow human in the loop training during post-editing, there's no clear line between human translated training data from MT generated training data. What are the pros and cons of this? I may quickly answer from the sort of our side running report. There may be a combination, of course. There's maybe dynamic training. There's also maybe just post-editing, and in this case, it will be very hard to detect if it's a post-editing or not. I think our goal is to make sure that the content we're working with, it took enough. It's not coming straight from the engine, and it took enough human effort to make it good. So if it's changed so much that it doesn't resemble original machine translation, we don't really care. And of course, high quality, right, Michelle? What do you think?
Yes, no, I completely agree. And I actually also wanted to address the other question that I see: could crowdsourcing improve MT quality? Are there solutions that have such methods? So, discussing with MT providers, they have been using a lot of crowdsourcing in the process of MT evaluation. So what they are doing is basically they provide a lot of annotators around the world, two versions of the same translation, as them, which one is better. So that's how they've been improving. But they realize that by using crowds, they're actually reaching a limitation where a lot of annotators, they would go to the how to say that, to the sentence that is that seems better, right? So actually, it was giving a bias towards more literal translation, because for some annotators who are not necessarily professional translators, they would, in many cases, not pick the best translation, but they would pick the one that is more literal, because it's easier for them to check that it has the same meaning as the original. So they are kind of getting a little bit away from that, and then deciding to work more actually with professional translators, with creators, with people who can provide to them this the naturality and excellence of translation that they are after. So they've been using crowdsource. It's not that they're going to stop, but it doesn't provide them sufficient. When now they are really at the edge, right? They are really doing. They feel that they've solved, maybe 95% of the issue, or whether maybe it might be 85, whatever the percentage is. But the remaining percentage of improvements are really hard to get by, and it's not very clear that annotation with crowd is the right way to get those extra percent. When you want like excellent quality of data, it's not necessarily good to work with crowd.
Yeah, thank you. I see some general questions. We'll take them just a bit in the end. Let's go. So as a result, we got 9 industry sectors. You may see colloquial, education, entertainment, financial, general, healthcare, hospitality, IT, and legal. So colloquial, it's not really a domain. There may be different domains in colloquial, but it's we included colloquial because it's a very specific type of content. And like when we work with commercial customers, very often we make one choice for long form content, and one model works, one customized model works very well for one company for all their long form domains. But for colloquial, we have to pick a different model. And you may think that, like in the non-technical way, you may think about that is that on the AI side, there is like a slider between fluency and fidelity. And for colloquial content, this slider like extremely pushed to fluency. For long form content, it's more like on the fidelity side. And you don't have control over the slider. So that's why one model may work significantly better for colloquial content. And 11 languages, including, and there is this question, including Arabic. Yes. And this year it's very unique. Before we had very spotty coverage because we had this data set if we found it somewhere, acquired it somewhere, ready to use. And now, since we built this data set, we have full coverage, all domains for all languages, which I believe very unique and very useful. Okay, from the, you may see some of the content samples here. As you may see, they're pretty in domain. And of course, for colloquial domain, having not really perfect grammar is a right, it happens. Then going to the evaluation approach, it's quite important to understand that there's no point in identifying MT engine with the very top score, because there could be engines which scores almost as high as the best one. So we don't know if they are better or worse in this case. And then we also know that scores are not fully correlated with human judgment. We use scores significantly correlated with human judgment, but they're not fully correlated. That's why if there is a small difference in scores, it may happen that actually in real life it goes vice versa, which we often see when we work with custom models, especially. It's very often that custom model gets high score just because that's how AI training works, improving the score. But at the same time, it may learn some critical mistakes, and then stock model may have lower score, but post editors prefer stock model for some cases. Of course, customization is typically a must-have. So what we do, our approach is to pick the top performing set of engines for the language and the domain, including MT engines which scores within a confidence interval of the best score engine. I will not go very deep into the details here, but there is a sort of, it's on the picture, you may see there is a confidence intervals, vertical bar of the scores, and engines which have overlapping confidence intervals, we consider them being the best, because we don't really know which one of them is best. We don't have enough confidence to say that the first one is the best. And for ones who know statistics, typically when you compare two variables like score, you consider 95% confidence intervals, which is different when you compare means of the variables. And so for the means of the variables, it's suggested to take 83% confidence intervals, basically to make intervals a bit wider. And there are a couple of references to the literature. Why is that? Okay, so we use a variety of scores in real life. And actually, when we run commercial evaluations, we use all of them just to see how they're correlated. But for this report, every year, we select the main score to use. And you may think that all scores, they split, they're all reference-based scores. So that's a score which can be calculated between human translation and machine translation. There are some other scores which are calculated between source text and machine translation. Those are different. We consider only reference-based scores, and they fall into two groups. One of them syntactic similarity scores, which basically they analyze how syntactically, like from the perspective of, we may say, letters used. It's not really letters what they use, but still how two strings are similar. And those are scores like LIPOR, TER, BLUE, which I don't show on this slide, and some others. There are other scores which show semantic similarity. So they do not analyze how strings are close to each other or how was the added distance. They analyze how meanings of two sentences are similar. They typically built on these multilingual embeddings like BERT, laser, and so on. This year, we decided to decommission n-gram scores, this LIPOR and TR, because they penalize alternative translations. And for the vast majority of use cases in the industry, you don't want to penalize alternative translation. There are cases related to legal and some other domains, but typically not. We run a separate internal study to decide which score to use this year. And if we'll have time, I'll show some results from the study. But basically, this year, we evaluated close to 4,000 models for customers. And for each model, we had all scores and the human judgment from 3 years. So we just, for our internal needs, we calculated correlation. And we found that the score most correlated with human judgment is comment. So we use comment of some specific version. It's important to note, however, that human judgment came mostly from professional post editors. And a certain level of intolerance to significantly different but still correct translations that post editors just do not tolerate. Just think about formal versus informal translation. Post editors hardly tolerate informal translations unless they're instructed to do that. Therefore, for tasks like gisting and for colloquial domain, maybe BERT score may work better. So in the report, you may also find results calculated on BERT score. For post editing, comment is the king today. Okay, with some questions about training, which we take later. Then this is the summary table of the report. It's hard to grasp, but that's the only way what I can show on one slide without significantly zooming in. It provides quick comparison of how many machine translation models show comparable quality per language pair and per domain, and also their relative quality between different domains for one language. So basically, you may see that you can take, say, French, and you see that for education in French is relatively higher quality. It's dark green. It's quite important to remember that scores are not comparable across languages. It's just doesn't work. And the reason for that, because different languages, they have different tokenization, basically different encoding of information. Because of this reason, whatever you calculate on top of this encoding, you cannot compare it if the language is different. So please do not compare blue score between, say, German and Chinese, and much like you can't really compare comment score. But you can compare scores in one language between domains to a certain degree. at least for semantic similarity scores. What are the main, and in the report, you may find more like detailed table where instead of color circles, you have logos. And that's just easier for a specific cell, it's easier to understand what are those engines. But here you may, for example, pick one engine and with this color look where you know, where this engine pops up as a leader, for example. What are the main things you may find here is that there are 16 engines which are statistically significant leaders for 9 industry sectors and 11 language pairs. And in the report, we have engine names. Just here, we typically do not show engine names when we present because different companies sponsor different organizations. We don't really want to or want to do vendor comparisons in public talks, but you can find it in the report. There are 16 different engines among leaders out of, as I mentioned, 31. And if you solve mathematical task of identifying the full coverage, like minimal coverage, you will find that you need 6 engines to get best results for every domain and language pair. And you may notice that many engines perform on the best level for English to Spanish and English to Chinese, meaning that it's relatively easier to find good performing engine there. You may notice that for legal, financial, IT, and healthcare, they actually require careful choice of MT vendor because very few engines perform at the top level. And also, you may see that for entertainment and colloquial domains, relative quality is pretty low, meaning that you see that for entertainment, the whole column is light, except it's lighter than other columns for every language, meaning that most likely for entertainment, you need customization because it's vast majority of domains. And for colloquial, it's a different story. It's about nuances related to colloquial content in that it requires context to translate properly. That's why it's pretty hard to do with using stock machine translation, even customized machine translation. So actually one of the things, I mentioned automatic post-editing, one of the things we do during this automatic post-editing is embedding context in translation, for example, tone of voice, gender, and things like that. That solves lots of pain for post editors. And you may get the full report by just using this QR code. Okay. Yeah, so that's, for example, possible minimal coverages for different industries. If you want to have all those language pairs for a specific industry, so you may see it go from 2 to 4 engines. Then another important thing we track is language support. Last year, so in 2021, it was just under 100,000 language pairs. This year, it grew to 125,000, mostly thanks to Newtrans, Meta, and Alibaba, which have the highest number of unique language pairs. But since we'll publish report in September already, Google added 24 new languages, Alibaba added 24 new languages, and Newtrans just about, I think, 1 or 2 weeks ago, 1 week ago, they added, let me see, they added around 84 languages, which are new to Newtrans, and out of them, 74 languages never had machine translation before, which is a lot. So very exciting things going with language support. And here you may see dark blue is number of language supported, and light blue is number of language number of language pairs, not languages. That's important. And light blue is number of language pairs unique to this specific provider, meaning that you cannot get those languages anywhere else. And yes, Yuli, you're right. Those are typically very rare languages or low resonance languages. Also, what we track, and I will speed up a little bit, I know we're short of time. So we track pricing, public pricing, and for some engines, you may see here price USD per million characters. Sorry, symbols, wrong word, characters. Some machine translation engines priced in USD per 1,000 words, then we just recalculate it using 4.79 characters per word. You may see there are some public volume-based discounts, but typically there are volume-based discounts available from any machine translation provider, for most of them, but they're not public. Also, what we track number of machine translation systems on our radar. Again, that's just what we noticed, because of course there are some which we don't know. And you may see how this number changed since 2018 from about 20, I think, to 54 today. And you see there are commercial engines. There are some engines were either in preview or in some limited availability state. And there's also open source pre-trained models. Actually, it's 4 after adding Meta and NLB, but also it's M2M and BERT and Opus. And we, out of these open source engines, this year we evaluated Meta, and no language left behind from Meta. I need to say it wasn't a fair evaluation as a machine translation based on massively multilingual model. Of course, in NLB is most beneficial for low resonance languages, but we haven't evaluated low resonance languages here. For these popular language pairs we evaluated, you may see that for English to Spanish, it's actually in a very top tier with commercial models. For 2 language pairs, for English to Chinese and English to Japanese, it's pretty low. And for others, it's basically in the second tier. And we evaluated 4 models of different size. Okay. So key takeaways from the report. We see that MT market is growing. 4 more vendors offer pre-trained models since last year. There's new open source model, and we evaluated 2 more engines than the year before. I already mentioned language coverage, and that's very exciting. And we know that it will be growing. So I hope we'll see 1,000 languages sometime in the next couple of years. I mentioned about 16 engines which are leading, with about 6 required to get full coverage for all domains for a specific language pair. Sorry, for all language pairs and industries we evaluated, but we evaluated just 13. We have some customers which work with 2,000 language pairs, so there's room to grow. Yep, and I already went through all that during that presentation. We see that if you work with Spanish and Chinese, it's easy to pick MT. If you work with certain domains, you have to be careful choosing your engine. And for entertainment, colloquial requires some additional customization or post-editing. Open source engines promising still for post-popular languages, you probably need to use commercial one. And Comet is a relatively new score. There are some already newer ones, which we will probably be looking at 2023, but Comet is the best for now. So I think we can take some questions. Then there are some bonus information which we may take if there's not enough questions. there's one question, general one, how we can claim that we translate 20 times more on same budget, just unbelievable, and what type of QA and post-editing applied there. Yes, it's I can answer. So typically the situation before we're starting to work with the customer is that they translate some limited amount of content with humans, say 10 million words per year, but they want to translate much more. They may want to translate 200 million words per year. And they just not translating this content today because they don't have resources to do it with humans, or humans are too slow for those use cases. For example, live chat translation or customer service. Just they're not doing that. And there is a huge backlog of projects from different departments which just not being processed, or systems where you don't have language support. You may have 10 languages on your main website and 2 languages in customer service, for example. What we do, we enable significant cost saving on the post-editing, through post-editing, about 70% of cost saving, up to 70%. And we, based on this post-edited data, we train models which are good to translate everything which is not translated today because there is no time and money. And numbers, for example, on Gala webinar, I think previous Gala webinar, or maybe there are some already between, it was excellent talk by IKEA, where they shared that they translate through post-editing 67 million words a year, and they translate through raw machine translation on demand 2.2 billion words a year, just one company. That's to give you an idea where this X20 comes from. Okay, then can you give an idea or accepted analysis? Could you give a rough figure of how many segments a domain-specific dataset must contain for a given language pair after cleanup and deduping? I'm referring to what your client must have already so as to train engine. So as a rule of thumb, we would say 20,000 segments. Technically, you may start training even from one segment for systems like Modern MT and Amazon, but I would not expect spectacular results from training on one segment. Maybe Michelle, you have some thoughts?
No.
Okay. Then, does it make sense to train an MT engine to translate general language content, or only in specific domains? It's a good question. And what we notice, we played a lot with using outside content to improve machine engine for a specific company. And what we learned that in many cases, it's more about the company which created this content and not about the domain. It's more important. And I think, like, if you take IT domain and you will look at, let's say, Microsoft and Oracle content, you may find that there's like 2 different languages. So if it's about enterprise content, then definitely. If it's for you translating news content, then most likely you don't want to. Okay, so rule of thumb, if this content is available in many languages online, most likely it already was used for training. So what you may add, you may want to add some sort of glossary on top to reflect to fix some issues with machine translation. But for example, for legal domain, in many cases, it doesn't make sense to train models. Thanks to European Parliament, which published the corpora, it was used by all MT providers to train the models. It's already in there. The problem is that if your legislation is very different from EU, then you may find some translations being really off. But that's you have to figure out. Can we actually use Meta as an LSP? Well, Meta is totally not an LSP. It's like a social network. Can you use it as a machine translation? You can, but I would say it's quite, well, first of all, you can't. Because if you look at licensing information, at least 3 months ago, it was licensed only for non-commercial use. And second, most likely you will find many deficiencies in features. For example, inline tag support, which is crucial for using in TMS system. You don't have it at Meta.
We have 1 more minute.
One more minute. Why does quick blitz? Why does IT domain doesn't perform at top level? Well, most likely because within IT domain there's lots of those different sub languages. Can you mention which is the best in quality open source MT language detector? I think there is none. At least we didn't find any, Michelle, open source MT language detector.
I don't know.
Sorry, MT language detection, you mean? I cannot tell you quickly. We use one internally. We use one from Facebook with our customizations on top.
Final question.
Final question. Would it be more comprehensive MT train model for the non-Latin languages such as Korean, Japanese, Arabic, etc.? Well, I suggest first of all to look at engines provided by local companies. If you go into Iberian languages, Elia and this contact may work better for you. If you go for Korean, neither may work better for you. Arabic, Tarjama, look at them. Customization depends. You probably don't have that much data for those languages. Okay. Yes, thank you. I think that's all we can take.
Well, thank you so much, Konstantin and Michelle. It was a gigantic amount of work that you did, incredible results and a lot of food for thought for everybody. Thank you so much. And thank you to all attendees who engaged with us during this presentation. Just a few reminders. I dropped in the chat the link to the post-webinar survey. You'll see the form also when I close the webinar, if you just wait 5 seconds. For those of you who don't know, we still have a call for proposals for our soapbox sessions to be held in Dublin during our annual conference. The conference is scheduled for March 12th to March 15th, 2023. And Intento will be presenting there. So maybe you would like to join us, but we would like maybe also to submit a proposal for our soapbox sessions. I dropped the link in the chat as well. And since we also talked about quality, we just opened the registration for our translation quality management event, 4 sessions in end of January. It's our Gala Academy event. I'll add the link to my follow-up email, so you won't have to look it on the website, and otherwise you can find it on the website under the event session. So this is all for us for today. Thank you again, Konstantin and Michelle. Thank you, everybody. And for now, have a good day or a good evening, and I hope to see you soon at another Gala event. Bye for now.
Yeah.
Thank you.
Thank you, Sana, and thanks for coming. See you next year. Bye-bye.
Bye.